Welcome. In this tutorial, we are going to learn about some of the built-in modules of Python. So let's begin with the math module, which provides the mathematical functions. So here are the constants of math module. First one is nan, which represents the not a number. Next is inf, represents the infinity. And if you prepend negative sign, then it becomes negative infinity. Pi returns the constant value for pi, and e returns the constant value for e. Here are the functions of math module. First one is floor, returns the floor value of given x. So here is the floor value of given float value, this. Next is ceil, returns the ceiling value of given float value x. So this is the ceiling value of given float value, this. Next is factorial of x, returns the factorial of given value x. So as you can see here, factorial of 5 is 120. Next is sqrt, returns the square root of given x. So square root of 25 is 5. It returns the float value. Next is f absolute, returns the absolute value of given float value x. So if you want to take absolute value of float, you have to use f absolute. So as we can see, it performs absolute operation on given float value. Next is copysign, returns the float with absolute value of first parameter x, and it copies the sign of second parameter. So for any type of first parameter, even if it is integer, it will perform f absolute function on that first parameter x, and it will copy whatever sign of second parameter. So let's see with the example. Here we have mixed float value with integer. So here first is negative float value and second parameter is positive integer. So it will perform f absolute, which will result in this, and it copies the sign of this, it is positive. So second one is a float value and with the negative integer second value. So first it will take absolute value of this and copies the sign of this. And third example is interesting. We have passed integer value and second value was also integer. So first it will perform f absolute, which will result in float value from the integer, and it will copy the sign of second parameter. Next is fmod, returns the result of modulus operator operation on the float value with the precision. So earlier we saw a modulus operator on integer value. Same way, if you want to perform on float value, you have to use fmod. So as we can see here, it is a modulus operation of on the given two float values. Next is fsum, calculates and returns the sum of float iterable by preserving the precision. So if you have a iterable of float values, here we have list of floats, and if you want to perform sum on that, preserving the precision, you have to use fsum. So here it performs the sum of given float. Next is GCD, returns the greatest common divisor of integer a and b. So here is the GCD of given two numbers. Next is isinfinite, returns true if the given value x is positive or negative infinity. So here we have stored infinity inside the variable, and if we check is infinite, it will return true. Opposite of that is finite, it returns true if x is not a positive or negative infinity. So here we have stored a finite value in x, and if we check is finite, it will return true. Next is isnan, returns true if x is not a number. So if we have stored nan constant, then it will return true. Next is frexp returns a tuple of two values. First one is mantissa and second one is e, such that x is the original given number equal to mantissa into 2 raised to e for a given float value. So if we perform frexp on a float value, so in order to retrieve the original value, you have to multiply first value into 2 raised to second value, which is exponent. Next is ldexp, which returns x into 2 raised to I. So it takes two value x and I, and it returns this value. So if we execute it, it will return 2 raised to 2 into 2 raised to 2, which equal to 5 into 4 equal to 20. Next is power function, which returns x raised to y for the parameters x and y. It performs on a float value. Next is truncate. It returns the integer value from the float value, truncating whatever the value after the decimal point. So as you can see in this example, it just discards the value after the decimal point. So if you want to check out more functions related to math, you can visit this link with the type of functions. Next module is random, which implements the pseudo-random number generators. So here are the functions of random module. First one is random int, returns the random integer between given two parameters a and b. So here random int 1 and 100 will return the random value in between 1 and 100. Next is random range, returns random integer beginning from 0 up to the given value stop. So it will not include the value given at a stop, but it will take up to the stop value. So writing random range 50, it will return the random value beginning from 0 up to 50. It will not include 50, but it will take a range of 0 to 49. Next is random range with the optional argument and first argument as a start. So it takes two mandatory argument, start and stop, and which takes one parameter step as an optional argument. So if we provide start and stop in random range, it will begin from the given number up to this stop. So it will begin from 10 and up to 20. So it will return the random number from 10 to 19. Next, we will see using optional parameter step. So it will perform step operation from beginning up to the stop, from start to stop. So beginning from 5, at each step it will increment by 5 up to this stop range 500. So beginning from 5 to 495, but it will not include 500. So from that range it will return a random number. And earlier we saw random int is an alias for random range a in b plus 1. So what random int does is invoke this parameter, takes this parameter, and it invokes random range function with the given parameter a and b plus 1 because this random range function does not include the value for the stop. Next is functions for sequence. So choice, which returns a random element from the given sequence as a parameter. So we have a strings and it is inside the list. So that sequence can be passed to the choice function, which will return any random element from the given sequence. So it will return a random string from the list. So as we can see, it has returned this string. So if you will execute the same function again, it will return different string. Next is shuffle. It shuffles the sequence X in place. So it will not take any other variable, but it will modify the same sequence. So it takes first parameter X as a mandatory parameter, which is a sequence to be shuffled, which must be a mutable data type because it does not create any other object. It modifies the object or a sequence itself. And second is an optional parameter random. It takes 0 argument random function which returns a float value in the range of 0 to 0.0 to 1.0. And by default it internally uses random.random function which returns the same value in this range, random value in this range. So if you want to perform shuffle using different random generator, pseudo random generator function, then you can pass that function here, which will return a random value between this range. And in random module there is a function called random which does the same. So every time you execute this random function, it will return a float value in this range randomly. So that is the by default implementation, but if you want to change behavior of this, then you can create custom function which takes 0 argument and returns random float value in this range. So let's shuffle the list of string. So here we are not providing any optional argument, just we are providing a sequence. So if we execute it, it will shuffle the given list in place. And if you try to execute shuffle for immutable data type, it will throw an error because you cannot shuffle the values for mutable data type. Next is sample. Returns the list of k unique random element from the sequence. So if you want to return more than one parameter or more than one value you want to choose from the sequence, then you can use sample. So it will return unique value which is guaranteed. So it will not pick one value more than one time. So let's execute. So as we can see here, if we execute it multiple times, it will not repeat the single value. It will always return the unique random element from the sequence, and it does not modify the original sequence. So it will return a new list from the given sequence. And it works on a immutable data type also, because you are not modifying the original sequence. You are creating a new list out of the existing element inside your given sequence. So same we can execute on the tuple object. So it returns string object of random unique element because we have provided value 2 as a k argument. Now if you want to shuffle a immutable data type using sample, then you can use this. So you can sample all of the element uniquely. Then you will get the result like this. Next is choices. Returns the list of which containing the k random elements from the population with replacement. So earlier we saw the sample which returns the unique element. Now this choices will return an element with replacement. So it does not guarantee unique element each time. So your element may repeat. So it takes this argument. First one is population is a iterable of items from which the choice is to be made, and k is the number of items we need to pick from it. So here we have provided 2 argument. So if we execute it, it will pick 3 numbers randomly by replacing. So it does not guarantee that your element uniquely selected. So here we can see the blue is selected twice. It takes optional argument weight, which defines the weight for each item to be picked up by the choices function. So here we have provided weight for each item. So you must have a sequence which has same amount of elements as you have the sequence of elements, which represents the weight for each item. So here we have weights, and if we give as a weights argument, it will pick up the items based on their weights. Next optional argument is cumulative weights. So it also accepts cumulative weights, and for the relative weights also, as we passed earlier, it also converts into the cumulative weights. So if you pass like this, it will also perform the choice operation on the given value. Next is function for real values. So first is a random. So as we explained earlier, random value takes no argument and it returns the float value between 0 and 0.0 and 1.0. So it's used as a pseudo random number generator for the other functions. Next is uniform. Takes 2 argument a and b and returns the random float value in the range of a and b in this range. So uniform 1.0 and 2.0 will return the value between this 2 float value. Next, how to manage random values. So for that, these are the function. So first function is seed. Seed is used for initializing the random number generator. So if you want to change behavior of how the random numbers are generated, you can configure the random module using seed function. So it takes first parameter a, by default set to none, uses system's local time to generate random numbers, and it can take randomness source such as from the os.urandom. So you can change that behavior depending on the time. By default, you can change it to this in order to change how your random numbers are generated. And second is version number. So by default it's set to 2, which converts bytes, string and byte array to integer by taking all bits in the consideration. And if you provide value 1, it for the string and bytes it generates narrow range of seed. So you should make it always 2, so which will consider all the bits. But if you are dealing with the large amount of data, then for the performance reason you might want to use value 1. So if you want to change the source of randomness, you can provide this value to the seed. So this way you can modify the behavior. Next is getstate, returns the object which captures the current internal state of generator. So you can store the current state of random modules generator random number. So by this way you are storing your random number generator state in the variable, and after modifying for the sum of the function, if you want to restore it, then you can use setstate function to restore the original state which is obtained by method getstate. So same state you can provide here which will restore it. Next is getrandbit, returns the Python integer with the k random bits. So you can provide optional parameter k. If you provide 15, it will return 15 bits, random bits, and it will be converted into the integer value. So 15 random bits make this random value, which is converted into the integer. Next is random number generator. So you can also customize the random number generator. So first is random, which takes optional parameter seed. It's a default pseudo random number generator used by the random module. So this is the random number generator you can assign, which is by default used by the random module. And next is SystemRandom, which uses os.urandom function for generating random number. So you can assign this also. So using this you can retrieve a random number generator, and you can use the random module function on that random number generator for your customized behavior. So earlier we saw a method seed which will modify the random number generator of random module. Now this will return a object. This will return an object which will be used to invoke the random module function. So your random module remains separate from it. Okay, so this way you can use independently of modifying the random module. Next is statistic module. First function is mean, simple arithmetic mean of given sequence, which works on integer or a fraction or decimal. So if we execute it, as we can see, it performs mean function on different kinds of values. Next is median low, returns the low median of numeric data. Next is median high, returns the high medium for the given data. So this is a high medium. Next is mode, returns the single most common data point from the discrete or nominal data. So here is our data, and if you want to take mode on it, so it will return the most repeating value here, which is 2.5, and we can also invoke it on a different values such as list of string, and if we invoke it, it will return this most repeating value, which is blue. Next is standard deviation, which returns standard deviation on given data with a given x bar value. So this is the result of standard deviation with the given x bar. So that brings us to end of the video.